Alright guys, in this section we're going to be discussing law of cosines. In the previous section we started talking about law of sines and we discussed 4 cases to solve oblique triangles. So if you recall the 4 cases here that we had before, we had angle, angle side, or angle, side angle, side side angle, side side side, side angle side. And we said the first 2 we're going to be able to solve with law of sines, and we saw that in the previous section. But now the remaining 2 cases are going to be solved with law of cosines. Okay, so that's what we're going to be discussing in this section. So here we have our formulas for law of cosine, and even though there's 3, they're basically the same formula. They're just depending on what angles or what size you're given, you have to take the correct variation, but it's essentially the same formula. And the alternative form is just when you solve for cosine. So in the case where you need to find an angle, that's going to be in our third case. When we have side, 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 the first thing you got to find is that angle. So that's where we have those formulas solved for cosine of the angle. Okay, so here in this example, we're going to see how to use law of cosines. And we have a triangle here, and we're given all 3 sides, A, B, C. Lowercase a, lowercase b, and lowercase c. A is 6 centimeters. B is 8 centimeters and C is 12 centimeters. Okay, and then we're asked to solve this triangle by finding the 3 angles here. In this case, we have to use law of cosines. So there's notice how you wouldn't be able to apply law of sines because you don't have an angle, right? And if you try to set it up, you won't be able to solve for any of the angles. So we need law of cosines, and take your pick. Doesn't matter which angle you find first. I'm going to find angle A, and we set it up here. We have our formulas here. Cosine of A is equal to B squared plus C squared minus A squared. All of this divided by 2 times B times C. And so plugging in our numbers, we get the cosine of A is equal to A squared plus 12 squared minus 6 squared. All of that divided by 2 times 8 times 12. Now that's going to be calculation. We can simplify that or just put it in the calculator. But remember, ultimately we want to find angle A. And that's what we have on the right is what cosine of A is. So simplifying it a little bit, we get that 172 over 192. But to solve for A, I'm going to have to use the cosine inverse, right? Cosine inverse of 172 over 192. And then put this in the calculator. And then we'll get that angle A is approximately 26.38 degrees. Make sure your calculator is in degree mode. All right, so there we have angle A. And now we need to find the other 2 angles, right? So if I find one more, the third one will be really easy because we can just subtract the first 2 from 180 degrees. But we need to find one more, either B or C, right? So let's find angle B. And notice how I could use law of cosines one more time, just like I did to find angle A. But since you already found an angle, in this case angle A, I could use law of sines if that makes it easier. Once you found an angle using law of cosines, you're welcome to use law of sines to figure out the other remaining angles. So solving for B here, we've done this before in the previous section. Cross multiply and solve for sine of B. That's going to be equal to 8 sine of 26.38 degrees over 6. We need to find B, not sine of B, so we need to use arc sine or sine inverse of that whole thing there. Okay, so once we put this in the calculator, we get that angle B is approximately 36.33 degrees. Okay, once we have our second angle there, we don't need law of sines or law of cosines to find the third angle. And we just subtract the first 2 from 180 degrees. So our angle C is going to be 180 minus 26.38 degrees minus 36.33 degrees. So we get the C is equal to 117.29 degrees. And there we have it. Let's see how we do a side angle side. Okay, so where we have one angle and 2 sides, not to be confused with side angle, right? Notice the order in which they give you the angle is not, the angle is in between the two sides, so we say side angle side. You can't use law of sines either, right? Because on law of sines you would need the angle and the opposite side to the angle given. In this case, I'm given angle A, but I'm not given side A. So even if you try to set it up law of sines, you won't be able to solve for A. So we need law of cosines. So looking at our formulas, we get that lowercase a squared is equal to b squared plus c squared minus 2bc times cosine of the angle A. Okay, plugging in our values here, get a squared is equal to 16 squared plus 12 squared minus 2 times 16 times 12 times cosine of 80 degrees. All right, so this is a pretty straightforward calculation, as we need to find lowercase a. So we're going to take the square root on both sides to solve for a. And on the right, we're just going to get the square root of that whole thing in there. And we can just put that in the calculator and get our answer for A. Make sure again that your calculator for this kind of problems, that they're in degree mode, so you don't get the wrong answer there. Once you put this in the calculator, you get that A is approximately 18.26, and this will be meters. Okay, just like we did on the previous example, once you found one side or used our law of cosines to find A, you can use law of sines now to figure out the remaining angles. Okay, so we get sine of 80 degrees over 18.26 is equal to sine of B over 16. Sine of B is equal to 16 times sine of 80 degrees divided by 18.26. All right, remember we need to solve for B, so we're going to use sine inverse of that whole expression. Putting this in the calculator, we're going to get the angle B is approximately 59.65 degrees. Okay, so there we have it. For our angle C, it's going to be pretty straightforward. Since we have the other two angles, I can just subtract those two from 180 degrees and we'll get our final angle here. C is going to be equal to 180 degrees minus 80 degrees minus 59.65 degrees, giving us C equal to 40.35 degrees. And there we have it. All right, so here we have a word problem where we're going to get to apply our law of cosines. We have in a softball game, a batter hits a ball to dead center field, a distance of 240 feet from home plate. The center fielder then throws the ball to third base and gets a runner out. The distance between the bases is 60 feet. How far is the center fielder from the third base? Notice here kind of set up a sketch of what the problem is describing. And we have here the bases, right, and that little square there. And they said that the size of the bases from base to base is 60 feet. The distance from the batter to where the ball went, where it dropped, is 240 feet. And we're asked to find what is the distance of that center fielder to that third base. So I labeled that as X, right? So it'll be easy to identify. Okay, well, this is going to be a classic case of law of cosines. You can see that we have the side angle side case because we know that angle is 45. It's, by the way, this is a square. So we set it up here by having x squared equal to 60 squared plus 240 squared minus 2 times 60 times 240 times cosine of 45 degrees. Just like before, we need to find x here. That's what the problem is asking. So we just take the square root on both sides, solve for x, and x is going to be equal to square root of all that. All right, putting this in the calculator, we're going to get that x is approximately 202.08. This will be feet. That is how far the center fielder is from third base. Right, here we have another example. A ship travels 40 miles due east and then changes directions, as shown in the figure here. After traveling 30 miles in this new direction, the ship is 56 miles from its point of departure. Describe the bearing from point B to point C. And bearing involves an angle here, guys. So we're going to have to find an angle there. So here we have the picture, right? And I conveniently label everything so that we keep track of our formula as A, B, C, the points. Well, the problem describes it that way as well. So make sure that when you do bearings, always I like to do my dashed lines of north, south, east, west, and I'm labeling the bearing that we're looking for because we want the bearing from point B to C. That's going to be this angle theta that I labeled here. So if we find that theta, we'll have the answer. Now for that, notice how theta is part of that B angle. So capital B, angle B, is going to be 90 plus that theta. So if I find that angle B, I can subtract 90 from B and then get my bearing, and then of course with my direction. So I'm going to set it up, law of cosines here, to find angle B. So using my formula, we get that cosine of B is equal to A squared plus C squared minus B squared. All of that divided by 2 times A times C. Plugging in our numbers, we get 30 squared plus 40 squared minus 56 squared divided by 2 times 30 times 40. And of course, to solve for B, I need to use my inverse cosine of that whole expression there. Now, simplifying it, I didn't have to do all that. You just put that whole thing in the calculator, but just simplifying this expression above this quotient, we get the B is equal to the cosine inverse of negative 636 divided by 2400. Putting that in the calculator, I get the angle B is 105.37 degrees. Now, my angle of interest here is going to be then that angle B, 105.37 degrees minus 90 degrees, as you can see in the picture. So then theta is going to be equal to 15.37 degrees. And that's my bearing. Now remember, the bearing includes the direction as well. So if you look from point B to point C, we're going northeast. So my bearing from point B to point C would be 15.37 degrees east of north. And there we have it. Now, one last thing here in this section would be another formula for area. If you remember, we had a formula to find the area of a triangle in the previous section with law of sines. We have another formula that is called Heron's area formula, Heron's formula, and that is the square root of s times s minus a times s minus b times s minus c, where a, b, c are our sides from a triangle. And this letter s is computed by adding all three sides and dividing it by 2. So it's going to be a pretty straightforward calculation. So let's look at this example here. I want to find the area of the triangle of sides 5, 9, and 8. And just want to do first is find this s, and s is going to be 5 plus 9 plus 8 over 2. That's 22 over 2. That's 11. We're going to use that s in our formula here. So we have a equals square root of s, which is 11, times 11 minus a is 5. 11 minus 5 times 11 minus 9 times 11 minus 8. We can simplify this a little bit or just put it in the calculator, but we're going to get our answer. Notice how this formula is very convenient for or practical for you want to when you want to find an area of a triangle or a triangular area and you don't have any angles, right? So if you don't have any angles, you wouldn't be able to use the previous formula from the last section. So this just uses sides here. So think about like if you wanted to measure the acreage or how much area you have on a piece of land that has a triangular area. Or even if it doesn't have a triangular area, you can split or divide in triangular area and just measure those sides. You'll be able to use this formula and find that area without having to figure out angles or anything. All you need would be just the measurements of the sides. Okay, so in this example, we have the area is equal to square root of 396, which is approximately 19.90 inches square. And there we have it.